I'm excited to share with you guys today the path to intelligent cloud and data center. And I know recently Calvin and I talked a little bit about this, I believe in one of the podcasts recently, but I'm going to go a little bit deeper and talk about what I'll call the telemetry of the systems and what's possible, both whether you're doing private cloud, you're doing public cloud, different combinations thereof. There is telemetry, it's critical, and I'm going to talk a lot about that. My partner in crime is Samantha Alt. She is a machine learning PhD. She wasn't able to join us today, but she is part of the tag team as she works on the business unit side, and then I work on the customer side, working with actually deploying a lot of what I'm going to be sharing with you here today. Okay, so let's jump right in. There will be a pop quiz on the legal notice and disclaimers later, just FYI. Just kidding. All right, okay. So I'm going to talk about Intel's vision on the intelligent cloud and data center. I'm going to walk through a couple of the solution domains and just kind of highlight a few of those solutions. Then I'm going to spend more time on telemetry, the Intel Telemetry Collector specifically, and I'll close it out with the modern autonomous data center and why that matters and how it all fits together. Okay. So let's get into the vision of this. The vision of the data center and the cloud data center is two things. Let's simplify and automate it, and let's reduce human involvement. So what needs to happen, whether that's the scheduling orchestration, whether that's the prediction and reliability, whatever that may be, we want to simplify it, automate that infrastructure, and then get people, again, out of the data center and get to that automated space and less involvement overall. Where does telemetry and AI come together? Well, it comes together, we believe, in this intelligent infrastructure. So taking the pieces of, we've talked about AI models in the past at Intel for, whether it is genomics, whether that is, cancer, just all these different aspects of using AI. The question is, can we use AI for the infrastructure? And the answer is absolutely. Okay, but you have to know what to look for and what to track. And again, I'll give more detail about that. The 4 areas that we're focused here is the performance. So system optimization, excellent experiences. The health. So failure prediction. How do I predict what's about to happen and know the sequence of events that leads up to it? Security, threat detection, threat response, and then power for energy consumption and thermal management. So these are the 4 domains that we have work at Intel that we're looking at, whether and again, I'll dive into performance a little bit more, less so on power, a little bit on health, security, just I think a flyby here. So let me go ahead and continue on. Now, as we look at telemetry in, like I said, cloud or data center, there are different phases of the modernization, of going modern. So I like to talk about the modern autonomous data center. It's a combination of up-to-date operating system, up-to-date software, as well as, current hardware generation, so that you're leveraging both pieces of it, whether it's updated kernels, whether it's updated stacks, whether it's specific hardware features called out. So part of, when I look at that part of the modern data center, I step back and say, look, what's the infrastructure and what am I doing? And these are the different phases of that modernization. So this goes from no monitoring, so basically I'm just running stuff, and my insight's very little, like what's happening, to exposing it. So saying, okay, what's really happening? And as I look at the metrics, then there's monitoring and action. So I'll expose it, I'll enable it, I'll monitor and take some level of action. And that action could be just, I'm gonna alert. I'm gonna send out a, alert on Slack to everybody that's supporting it, the app developers or to the app owner or to the contact, right? The action could be very limited. And then when we get down to controls and prediction, now I'm going to do something with it. So I will do a control function, I'll do a prediction function, and I will expose something else. So that could be, hey, we've got a DIM that is responding in a very interesting pattern where there's different CEs, correctable errors that are happening on specific rows and neighborhoods, and now I need to go do something about it because it looks like it's on a path to failure. That would be a prediction in that control. The control aspect would be, I'm going to start draining it. I'm going to start moving workload off that machine. So what's the model? Is that, on the picture on the left, it's, you have got a data center, you got your cloud instances, You're going to look to the specific metrics. So what metrics are you going to watch? Identifying the thresholds, and then getting to that alerts or auto fix. So this is the kind of the perfect, closed loop automation solution that we look for, is expose the right things, take a behavior change, feed it back in, make sure we're still tracking, is it reacting the way it should be? So the 4 domains, because we click in now into the infrastructure, we start to look at infrastructure efficiency. So how do you get the right, improve utilization, get more workload density in what you're already operating? So an example of this would be, in the past we talked about data center density, and I want to pack in as many one-use systems into a rack because I've got a certain power budget and I've got a certain thermal footprint. Think of this for the cloud on how do I get to that workload density I need on a specific instance? Do I have the right instance, and am I using it to the best of its ability, like packing as much on it as possible up to the point that I have purchased? You look at reliability. So reliability from a failure prediction. So one of the things I mentioned just a few months ago is memory failure prediction. And that has been one of our biggest items with the customers last, 2.5, 3 years that I've been on the road with customers, has been, hey, memory's failing. It is the next big failure point. How do we get ahead of it? How do we use the telemetry and that rich information to understand what's happening and when it's going to fail? And I'm actually going to show you a piece of that ML today on how that works a little bit and how we're doing the detection on it. Security, threat detection, response, and then performance. Performance is actually one of my favorite areas because it's all about how are we doing the optimizations, so the hardware optimizations, the software optimizations, to actually eke a little bit more performance out. So whether it's finding the bottleneck, or if it's I want to get more out of it, how do I do that? And there are a couple of tools I like to advocate and show and use, and at the end, I'm writing blogs on it. I'm throwing videos out there on how to do this stuff, both for on-prem and cloud. Just as more of a point there. So continue on. So what are the pain points around the infrastructure, the systems, the stack that are of concern? And then what are the solutions? So I talked a little memory failures. We got a failure prediction model. We got low utilization. We got a workload efficiency solution, where we look at, specific footprint of it. What is it doing, and look over time. Power constraints. On-prem matters. I would, there's comments on, okay, if I've got a specific, instance I'm paying for, what is my actual power? What am I actually utilizing? That's important. Too hot thermal, usually that's on-prem, and performance bottlenecks is in both cases. And this is just, like I said, a great area to double click into to figure out how it works. Now, one thing I haven't talked that much about, and I'd be excited if you guys want to talk about more, is around using telemetry to actually do workload placement. So it's not in my material today, but if there's a question on it, when we talk about being able to detect all the features of the system and making a smart decision. So we look at things like Kubernetes, and we look at the scheduling portion of it, being able to say, okay, what is the metadata of the workload I want to send, and does that machine have AVX 512 or not? Does it have, yes, you could do CPUs, memory, and storage, but we can go even a step deeper and start to look at those Intel features. So I'm not going to talk about it, but it's still underneath this telemetry domain. And I don't have foils on it. I'd love if there's questions about it. I can go deeper on that. Let's talk about low server utilization. So this is one of those domains that we think is important on, are you utilizing the fleet effectively? And through our analysis and looking at different, customers and fleets and, farms, we realize that there's different patterns that start to happen where we don't see systems at that sweet spot. And so we're seeing things that are, low on the, memory utilization, but they're high on CPU utilization. So there's questions on, okay, what's happening? Is it a CPU intensive workload or not, or are we not seeing the right behavior? Usually we like to try to see a sweet spot, and that's in this kind of this 60, out here. It's like a 50-50, 60-60 out here. We like to see that, where the systems are all operating where we still got headroom, but we all know that you want to see that they're being utilized. Whereas like you see down here in the bottom left, it's like machines are not being utilized. So if you're, you're pulling in more instances, you're pulling in more servers, the question becomes, okay, am I effectively utilizing my machines, and then what can I do? Now, this is part of that exposing. So you can see that you have a challenge or an opportunity to go after. The next step forward is we start to layer different workloads on top of here. So perfect opportunity to layer learning, right? So a training workload and putting it onto those machines. So as they're not being utilized, you can actually apply more to it.
Hey,
Now,
Josh.
yeah.
I have a question. Let's say that I am a cloud consumer and not necessarily an operator of a data center. How would I utilize this type of solution for my cloud deployment where I'm not necessarily worried about the physical boxes, but maybe I want to maximize my investment in, the virtual machines I'm running or something similar to that?
Yeah, no, great question. Thanks, Ned. So the tools that I'm talking about, like Collect D and one of the profiling tools, work on cloud instances. So I can actually mock the same behavior you're seeing right here on your cloud instance. Look at, okay, am I using of the CPU I have purchased? Am I getting what I expect out of my full utilization? How much memory am I really using? Can I start helping with that right sizing or scoping? So you could have the same type of behavior. In a few moments, I'm going to talk about the profiling tool that'll allow you to do that same kind of behavior as well, to look at things like true utilization, CPI, right, cycles per instruction. You'll start to look at frequencies on, are you getting what you should be getting out of that instance? So
Okay.
yeah, no, yeah, because I get, you go into cloud and you're like, well, do I care about power and thermal footprint? Not really, right? It's like, not my problem, right? That's why I went to the cloud, right? Now I'm worried about, okay, if I chose an EC2 instance, M5X large, am I getting everything I want out of that instance, right? Or, I throw a VM in there, am I getting everything out of that? Am I truly seeing it? And am I underutilizing? If I am, that's wasting money. How can I get more onto it? So I'll be going after, I'll show that in just a few moments. Good question. So reliability. Now reliability, this is where we talk about memory reliability. Now, yes, in a cloud space, if you're using using metal, I would say this is something that's of high interest. If you're using IaaS, the question becomes on how much insight do you have to specific error logging? But in a lot of cases, I've seen that you do have access to this, which I think is important if you're trying to do some level of planning. Now, some of the CSPs that I do work with are started down this path of using memory reliability to assist from providing a better service to the consumers of the cloud, us that are buying services on the cloud. But in the cases of the bare metal instances, this is a great possibility. So what we're using is a driver called EDAC, which is Air Detection and Correction Driver. It comes out of DMESG, so it's a low level and starts to give you pattern information. And when I say pattern information, what that looks like is, let me hit play here, see if it plays. So what you'll see here is that as the data is coming in around a specific DIM, so it's at the DIM level, what it'll start to do is tell me, where am I seeing correctable errors hit in the pattern? And so how if you look at the DIM topology, you've got columns and rows. And so as you get CEs, it starts to tell you where the specific CEs are coming. And through a lot of analysis and correlation, we've realized that there is a pattern. And in the more concentration into a what's called a neighborhood or a column or row, the actual pattern of failure becomes very predictable. So what you're looking at is kind of, you see here that the health score is changing on the right. That's part of our ML that does this. That's reading all the information and pushing out a score. So you can kind of get an idea of when it hits around 60, it's time to actually do the next step, whether that's move workload, whether that's alert, the CSP, or alert the tech, what have you, to say, hey, look, this DIM is about to fail. We've got it down to where, within about an 80-90% range, we can predict that when it's going to fail. And our ML model tells us when, like how far in the future. So what you see here is this column just got lit up over time. and now we know it's time that it's time to replace it. And there's examples we can give in the hardware space, but from a cloud standpoint, it's like, hey, that's my a very good notification to the CSP. Hey, look, something's about to fail. I need you to check it out. What's exciting for me is I love, from a telemetry standpoint, I love knowing that it's not imaginary. It's not snuffleupagus, right? It's not an imaginary thing that's out there. It is something that's real. I get the data. I can then, predict off of it and start to shift, move workload. And I don't have to worry about, flipping around my SLAs or kind of ruining my customer experience. Now I'm going to continue forward and talk a little bit about performance. And stay tuned. If you've been thinking, okay, Josh, SimScript looks like maybe it's on-prem, or maybe it's, it got a flavor of on-prem, but a little bit of cloud, I'm going to hit that mark right now. What will wake you up at 3 a.m.? Like, for those that I used to run an IT data center, and getting those text messages when we had a server out or a service out were very frustrating, or a application went down. And so these are what's going to wake you up. It's an SLA violation, right? The one that irritates me the most is a gray failure. Hey, it's slow. Okay, nothing's down. I see my dashboards are all good. I see that my instances are up. What's happening? And so as we look at what are the type of issues to dig into, we then go into, okay, let's collect the right telemetry. So for public cloud instances, can I get this data? I'm going to tell you right now, I'll beat the punch. The answer is yes. Okay. So what are you going to be able to get? Intel platform monitoring units. So if anybody's heard about Intel PMUs, this is it. They are different. We have our own that are specific counters. They're low-level counters, and it'll allow you to get certain information like CPI, cycles per instruction. So this is helpful when you are troubleshooting and understanding the health of your application or your VM or of your service, to know how is it behaving. Now let's go one step further than that. What if I'm running a container infrastructure? Can I get a CPI container? Bingo. Yes, you can. Now I'll go one step forward. We're working on, actually there's some stuff I'm working on right now around going to the PID level. That's coming up soon. I'll probably put a blog out hopefully in the next month on PID level PMUs. But we've got CPI, utilization, frequency, and TMAM. So utilization, what am I getting, right? Is it working as expected? So Ned, to your other question on when I go into the public cloud, can I get this data? How does it help me? Well, this is where it helps you, CPI and utilization. The frequency is important on if you're using, depending on how you're using the system. So I'm using a bare metal system. There's specific things that I need to validate in the operating system to make sure it's working as planned. One of those things is the CPU frequency governor. So why does that matter? Because I'm not going to go, am I going to go into performance state? Am I going to go to power save state? Am I going to use the P-state driver correctly? A lot of those things are part of why you would not get the frequency you desire, or you wouldn't see the optimal run. The last element on here is TMAM. So TMAM, I'm going to actually spend a whole foil on TMAM in just a minute. It blows my mind when we start digging into TMAM on what you can do at the application level to really make sure that you're optimizing your code and getting the right of it. But let me just keep working to the right here. So what can it be used for? Workload characterization and profiling and bottleneck analysis. You may, I wrote some code last year. It's actually what's on the right, Intel Telemetry Collector. I ran TMAM analysis and realized that I actually have some back-end problems. I have back-end bound, core bound problems in my code, and had to go back in and refactor and think about, okay, how am I running it? What am I calling? What's the frequency of my calls? So very intriguing and helpful when you're trying to get more out of what you're paying for in the cloud. So on the how to get access to it, we've got a tool, Intel Telemetry Collector, that we provide. Just ask your Intel rep. We'll get it to you. I'll give you access to it. Or you use perf. Perf, cAdvisor, collect D. So the reason I'm calling out cAdvisor down here is if you're using Kubernetes, right? So you're using, EKS, right? You're using a Kubernetes service. My recommendation is to look at cAdvisor. So it's Google's container telemetry we have upstreamed our Intel PMU support into cAdvisor. So for, if you look at how you're doing telemetry for the containers, you get all this, of course, this rich telemetry, but then you can actually increase it to all the PMUs. So I can look at a container level to all the stuff on the left, CPI utilization and frequency, which is helpful on how are my containers really running? How are they operating? Now I can still, in a VM, I could run the same thing where I would put maybe a container on it, or I'd throw a collect D on it, put another open source agent on there to grab that same type of information. All right, TMAM. Woo! All right, top level microarchitecture analysis method. Why does this matter? Again, I think I've talked a lot about this around being able to dig in at that level to figure out where it is. There's some really helpful tutorials online of being able to pull up your application instance, whether on your on your public cloud instance, run TMAM against it and validate that you're seeing. Like, what are you seeing from a behavior? Where is it failing, or is it having bad speculation or retiring? So if this is of interest, I'd say definitely look at the optimization manual, or there's some really great blogs. And I'll try to tweet them later on Twitter. Actually, when we get off the call and I can actually pull up email, I will tweet a couple of those out on a couple of articles that are not from Intel, but how to use TMAM. And how I would, and I like the models that this gentleman provides, and are very helpful, and I've actually used them. So again, getting down to like, where's the bottleneck? What's happening? Am I getting as much as I can out of the instance I'm using? We'll skip by PMUs, and there's the answer. You probably guys are asked, like, hey, great, this sounds cool, but can I really do it on a CSP, or is this all just on-prem? The answer is nope. You can do it on the CSPs. Yes, there are specific instances that are available to do that, meaning they have access to the counters. Of course, on PaaS, you cannot. That's obvious, right? We're using a PaaS service. SaaS, the same, but we get into infrastructure as a service instances, you can. And actually, just a quick moment on instances. We have a tremendous amount of Intel instances on every CSP. And I'm not trying to be too commercial-ish on this, but it is important based on what workload. So like, for example, when Gary was talking earlier about SGX, you're looking for instance that has SGX, right? When you're doing something that needs AVX 512, you're looking for it. If you're using a workload that is like SAP HANA, or you're using Microsoft SQL or MySQL, there are instances that are optimized for that specific software. So it really does matter. And so from a telemetry standpoint, I look for the right instances. Sometimes it's a little bit tricky to find the right ones. We're starting to do a better job of articulating that to everybody outside of Intel, and like, hey, these are the ones. Right now today, it's a little bit more, I'd say, organic, where we start to post them, but we are going to get better at kind of publishing that out so that everybody knows kind of what to look for and what it'll do. All right. And I'll keep going. So yeah, you get the visualizations and you get no 3 a.m. calls. Yay! That's actually, maybe it's a little bit, that's the first step, I should say. So once you start to do the whole detection, exposing, and getting to that state. All right. Let me pause for a moment before I get into more around telemetry, because I'm going to go a little bit deeper. I know when I was talking to the team, I said, how deep can I go? And they said, you know what? Go as deep as you want with telemetry. So I hope you guys don't mind that I'm going to go deeper, but let me pause and ask if there's any questions.
Hey, Josh, I have a question. Instead of going deeper, let's zoom out for a moment and kind of, who is this product for at the customer side, and how would they go about consuming it and adding it to their existing operations? Because I think we went right into the weeds, which is awesome. Like, I love getting into the weeds, but I'm trying to figure out who's the person who's going to be using this and how do they actually use it?
Yeah, no, good one. So I'm not really, yes, I'm talking about one specific software tool set that's in here, but let's just talk about telemetry at large, right? When I look at who should be using telemetry, it's if you care about your operations, if you care about the efficiency of the instances or the VMs they are using, This to me is important. So who would be the ones using it? I would be looking at procurement. Am I getting, we've purchased all these instances. I get the bill every month. Are we getting true efficiency out of what our investment is, right? So there's the procurement angle. From an engineering standpoint, whether it's DevOps or more like DevOps and engineering is it operating as it should? Am I getting the performance I expect? Am I seeing the SLA that I expect? Like whether it's a latency conversation, whether it's am I getting the throughput that I'm looking for? So when I look at engineering DevOps, it's that, right? Is it operating as it should, as we spec'd it out to be? If it's about, and those are the two, like I'd say, key audiences that are, from a purchase standpoint and from an engineering into the cloud.
Right. Let's say I'm in procurement and I want to make use of this to check on things. A procurement person is not going to be comfortable with the command line or with a lot of this verbiage. What does the product look like that they're consuming to get their job done? Is there like a dashboard? Do you deploy this as a service? I'm just trying to get an idea of what this product at a higher level actually looks like before we get way down into the bits and bytes of how it works.
Yeah, no, gotcha. I would look at this as from a deployment standpoint, and this isn't make clear. There's some dashboards, operational dashboards you can get on the CSPs, right? I've seen them. Yes, I use them. When we're talking about this lower level stuff, this requires, the engineering team to, basically integrate this in, and the facing to the procurement would be simply a dashboard. It would be just show me all of our instances on top of each other with their utilization, and are we getting what we paid for?
Okay, so it would be incumbent on the engineering department to take these tools and frameworks and everything and build a dashboard for procurement.
Yes, and we have some examples but this I'm not pitching to you guys a product today. I'm more talking about the technology of what's there and what's possible, and how I've seen customers use it.
Okay, gotcha. All right, that clears it up for me. Thank you.
Yeah, I'm not selling anything. Not today. I mean, by Ice Lake, again, soon, but no. But I'm not pitching a product. I'm just showing what's possible, because a lot of times telemetry is overlooked, right? It's like, nah, why do I care? I'm paying for this stuff. It starts to become important when you start to look at the cost structure and you start to say, okay, what am I? And that's where I have spent a good portion of my time, is starting to get that conversation of like, am I being as efficient? I want to spend the same amount, but I want to have higher workload density. I want to know when errors are going to happen. I want to have better insight. So,
hey, Josh, just wanted to then chip in. So I can see some sort of a use in, for example, the big organizations, CSPs, those kind of people. So if what you're showing here and the section before, like telemetry, but also AI, and looking at problems before they happen or predictions, is that going to a point where there is something that can be easily consumed in terms of triggering a process where automation kicks in based on that telemetry and AI and says, yep, you're running all this workload on this system. Say it integrates into, say, VMware, where it sort of introduces another host into a cluster, moves everything across, takes that host out of, now some of that was already built into VMware. But what I'm saying is that if we are saying that these tools then are being exposed to different applications that can build automation based on that, then yeah, definitely, I mean, the engineering or whoever can then integrate these into their own operations and processes, and it becomes a useful tool to them. Otherwise, yes, some engineers that will be working on it and making things efficient, it'll be a great tool for them. But I can only see the value of organizations looking into this very deeply, apart from playing with technology, if there is automation as well that can be plugged into this.
Yeah, no, it's a good, and the short answer is yes, we have we've started to upstream more of those automation tasks. So workload co-location agent is one of those. It's already on GitHub. It's out on Intel's GitHub. Actually, I'll show it at the end and my reference links as an example of taking all that information in of all the telemetry, all the PMUs, and then when there's a behavior change, they're basically telling Kubernetes we need to move. I think what actually I'm trying to think if the Kubernetes code went live yet. I think it's OpenShift is out there. I want to say. I'll validate here in just a moment, but the workload co-location agent does that work. They're saying it does the automation part. It starts to shift the workload from a integration of this telemetry into things like VMware. I haven't seen that completely yet that I'm aware of. I probably need to dig in a little bit deeper with VMware, but I haven't seen that yet.
So would you then expect the vendors to come to you to build those tools, or would you help or work with vendors to build those tools so that those applications can take advantage of all what you're presenting today?
No, absolutely. No, and we're doing that. From a ISV standpoint, even the top CSPs, we're having those exact conversations and giving that level of insight of what's possible. So yes.
When you're talking about like the Kubernetes scheduler and using PMUs, it sounds like there's an opportunity there with the telemetry that you would collect to be able to better understand the current load on the workloads, the kind of hardware is available for a specific kind of workload, and actually being able to distribute and schedule specific Kubernetes workloads to specific kinds of nodes based on the hardware that's even available, or being able to leverage hardware that's not normally accessible or not known by the cloud provider because they're not providing you that data, but the PMUs and the Intel bits can actually tell you that.
Absolutely. Yes, Calvin, yes. So yes, having that level of insight to what is physically happening on the box with that insight or the instance, what's happening, and then being able to make the smart decision with the scheduler. So yes, absolutely, that's a huge insight. Then plus the second part of that is there's the insight that gives you that automation, but there's also still that exposure to understand what is really happening. So you're aware of, okay, how are those containers behaving? Is there some unruly container that keeps blowing up the system? I've seen that a few times where I'll see a container kicks off and the CPI goes way out of control, and it's like, okay, that's a very inefficient container. We need to go back into that container and figure out why. Why is it operating that way? Why does it have that kind of a footprint when it kicks off? Versus what we would expect as normal behavior, like a certain range of the PMU. All right, let me we're gonna fast forward through here, and I'm gonna just go right into a little bit about the collector. So I'm not, and by the way, I'm just providing this Intel Telemetry Collector software is just kind of more of a use case example of how we're doing it. Now, this why we wrote this tool is that we were getting questions around, can I take my instance, my infrastructure, and what can I do in a automated way? How can I pull the information together to see how it's operating? And so we built a couple of tools on top of standard repo items. So perf, ipmitool, dstat. Now, when we talk about instances, some have IPMI access based on if you're bare metal. Some you don't have IPMI access, so you're not going to have specific things within the OS you can get. Perf and dstat, again, it's based on instance. Most of the discrepancy I've seen is around ipmitool and if I have out of band. So, but you can pull. We wrote a tool that grab those specific things, looks at the top metrics, like our top low, kind of the low hanging fruit items where we know there's a configuration or we know there's a software element that we need to go look at. And we built kind of this pipeline of being able to run it, collect the information, and push out to the visualization. So who would be using this or of interest is any developer, app developer, DevOps would be of interest. This is not per se for the procurement side of the house. This is going to be on how is it operating, what's happening. And so we've got this end-to-end stack that's running. That's all open source based. From a how we do our TSDB, we're using ELG, so Elastic Log Search Grafana. We replaced Kibana with Grafana, but we're using that kind of open source infrastructure to be able to collect the key metrics and then pump to the graph. So again, developer, DevOps, someone's looking at, okay, how is it behaving, and is it behaving as expected? So the things that we get are, yes, depending on the type of system. If you're doing bare metal, you get some of the NUMA. If not, you of course you won't get that because of the type of system, but you will get into the CPU frequency and CPI that we already discussed. Let me just fly by that, and of course the output. Now, the next question is, or that I usually get after this is, how about if, so I've got these instances, I already have a dashboard going with some level of, health, whether it's the health checker, whether it's, you're looking at the watch, you're looking at what's happening, but how do I go from there to actually getting to this? And the answer is we go to scale it, and we use things like CollectD I talked about earlier. CollectD is an open standard. It's something that Intel has spent a lot of time investing in, from upstreaming all of our features. So whether it's PMM, persistent memory module, whether it's Optane SSDs, whether it is the PMUs, we've upstreamed all that into CollectD so you can deploy that agent across your nodes and get that level of PMU data. So, and I would equate that to, you could deploy that to all your instances, run the agent, and be able to pull that back to a single dashboard. And then with container, I talked a little about cAdvisor and working with cAdvisor to then look at container instances. Now, if you're in the VMware shop, then the question becomes, okay, what's possible? And there are tools in VMware where you can start to get some of that perf data. And so we have written kind of a reference package for VMware on getting the specific PMU data through VMware. I don't believe we've published that externally, but we have it available. I'd be more than happy to pass out kind of our latest work we have on that. But the goal would be to start to get that same kind of PMU analysis within VMware, within the VM.
Can we hit in on the AI and detect when something should have happened that didn't happen? I mean, is that where we're going with these kind of models? If an operation that normally would happen on some regular schedule, can we do some kind of anomaly detection there to understand that we should alert when it does not happen?
That's a good question. Yes, if we know the pattern, if it's an expected pattern, I would say yes, we can. I'm thinking about how I would do that. I know it's, yeah. So the correct answer is yes, that's possible. How we've been looking at AI today is consuming everything, consuming the right stuff and putting everything into the model and then making determination based on that. What we haven't determined is the absence of or the lack of. That would be a very interesting way to approach that, is going in that direction.
I am also very curious about AI ops type applications for all of the stuff you've been talking about, because that's where the rubber meets the road to me is. And this might be the topic of what you're about to talk about, is how you put all this stuff together to automate your data center operations.
So putting all the pieces together, right, Ned? Right, that's the thing, right? Is how do I put everything together? And that is truly the vision of this, the modern autonomous data center. I'm going to show you a little about reference architecture, but I'll tell you, like, this is the kind of the big push we have inside Intel right now is AI for ops. How do we, and if I could go one step further than that, it is, how do I take all of the components and the smartness of each of those components and feed them into the AI model? And that is absolutely what we're working on right now is, okay, let me take all the pieces of the stack, let me take all the pieces of the underlying hardware. And again, if I am in a SAS and PAS, that's a different, of course, equation. If I'm in IaaS, yes, it's about being able to leverage and pull the smart information into the model. So this is where we're focused on now is, okay, what AI models do we want to build for operations? What's our consumption of that? So that when I talked earlier about the scheduler for Kubernetes, that's kind of one of our first big pushes of how do we get into the orchestration to make the orchestration and scheduler smart and to know what's happening and have that level of insight. And things like with Platform Resource Manager, we've added in the RDT hook. So the Intel Resource Director hook. So when there's cache and we have a noisy neighbor behavior, you can then react based on that and then be able to shift workload and move between best effort and latency critical workloads and shift them around. So that's where we've pushed down that path, more so. But what we're focused on right now is doing exactly what you said. So I have nothing to show you on that concept yet. Of working, the best AI models that we have working are we talk about DIM failure, we talk about the workload co-location agent are the best examples, but we are absolutely focusing on how do we put all these pieces together and start to get to that kind of that Skynet.
I guess in general, you're trying to generate as much machine data as you possibly can, knowing that it's going to be analyzed by another machine, right? So people are never going to be the primary consumer of this information. You're going to crunch it on the back end and then take an action based on that.
Yes. So yes, Mike, the only caution that I'm very I trigger into is I don't want to do anything recreational though. Right. So it's like I don't want to recreationally collect everything like mom did in the 90s, right? Microsoft Operations Manager, where you just got inundated and pummelated, right? But
I did see a slide that said recreational telemetry.
Yeah, I flew right by that. But yes, I don't enlist in the recreational side of it. But it's yes, there are certain things that even when I talk to customers now about this, I say, there are certain things you're going to want to proactively start to collect because they will become valuable. Whether it's DMSG output, whether it's your container telemetry, things that are of high value that soon we'll be able to pipe all that in and run it into the AI model and say, okay, how should this worked? What should I have provided as an instance for this? What are the optimizations I should go after? So yeah, that's the future path. But I don't have a demo to show you, Ned. I'm sorry. Today on this call, I can set that up. Shauna was rightly so. I can set that up and share that in a future session on what we have so far that's working in this area and kind of the direction we're headed. But this is to an infrastructure guy like me, and I care about telemetry. Hopefully you guys are feeling that from me. That I love working in this space. Getting to that AI for ops is absolutely our goal of getting to that, taking the automation to the nth step, getting people out of the dependency loop. And I think, so as just a re-hit back on the different phases: expose, monitor, control, full automation, complete automation. So this is where we're spending our time. Yes, we've got the right counters that are exposing, so the right Intel PMUs. You probably heard me say that a number of times today, but we've got counters and they're specific to Intel. And we have the right, we have the specific formulas that tell you what it is, what's the behavior that's expected of it. We've now are spending more time on how do we get to that true automation. We see things from some of the big CSPs around like automated thermal control. I think Google had that, or they do their own, the machine does the thermal awareness and changing of the crack or the craw. But we are going further with, okay, how do we do that up the full entire application stack with the orchestration and the scheduling, with the shifting of workload automatically and what have you. And I know we're about like 12 minutes till, but here's everything that's I'd say relevant to this whole conversation of all the different types of tools. Most of you'll see is on, or a good portion of this is on Intel's GitHub. So it's open source, like the orchestration orchestration aware workload co-location agent, the PRM, some of our Intel CMT CAT, which is our cache management technology and cache allocation technology under RDT. and then including C Advisor and some of the new PMM stuff that's been working on for persistent memory module. So if you have more of a higher interest, I'd say, dig in there or dig into one of the blogs I've talked about this, including some of the tools for transformation and what have you.
As an old data center guy and as a VROPS guy from way back, I really appreciate the need for telemetry and the pulling of data like this, and I'm excited to see what's going to happen with the automation pieces of this, because we've always we've retroactively taken care of these issues and watched things get hot, but the implications of the proactive ways to fix these things are pretty exciting.
Excellent. I agree. That's when I'm working with a customer today on doing the memory failure prediction, and when I start to look at the DIM output and I start to see dates of when it's going to fail, it gets me very excited. And maybe I'm the only one, but it's like I get really excited and go, oh, a failure's coming up. Because with that knowledge, Chris, right, it's like I can now do something about it, right? And
Exactly.
we'll start feeding that into the automation loop. Say, all right, cool. Send a tech, or depending on the box, rip and pull, right? Rip it out of the rack and put a new one in, right? It just depends on whatever the model is, right? So no, it's a great comment. Thank you for adding that.
Yeah, totally.
I also want to comment that I think it's an excellent show of open source goodwill that there is a lot of GitHub links, in your relevant links, that you are putting out reference implementation, showing people the way they could possibly use these technologies in the cloud for doing their workload scheduling, for understanding the telemetry, because that's not an easy subject, and it's always better when you got a good example to follow.
That's a great point. And I know one of the things that I would like to do more in this space is, yes, I have my own GitHub out there, is to post some of more of the instance-based reference as well, of how I would deploy it on a M5X large. What is that specifically? How would that work to show as a reference? So I assume I'll be working on that and showcasing that now after today's call. I could post more of that. Good deal. Thanks, Calvin.
Now, going back to the point I was mentioning earlier as well, that this orchestration, all this data definitely is valuable. The tools, all this wealth of data. If only, I can see you are going to all the vendors, and if that's done proactively and actually built into the products, that can be very useful, because there are many vendors, monitoring solutions, all of these kind of things, platforms that can take advantage of all of this and take proactive actions based on this telemetry and IOPS. And if it's not already there, we're not seeing it, then maybe you can just proactively go and work with them and make it happen.
Fair point. Heard, and yes, agreed.